On Earth, volcanism is a result of internal heat of formation, but on Io, which is too small to hold on to this heat, something completely different must be happening. Something else was driving volcanic activity.
That something was the powerful connection with Io's parent planet. Io sits about the same distance from Jupiter as our own moon does from Earth. Orbiting outside Io are its larger sister moons, Europa and Ganymede. Io isn't only under the influence of the massive gravitational pull of Jupiter, but also the additional pull of its neighboring moons. For Professor Brian Cox, these simple connections are a perfect example of how basic physics can breathe life into what should be a cold, dead world. Because this gravitational tug-of-war turns Io into a wonder of the solar system.
These three moons are arranged in a very interesting way. For every one orbit of Ganymede, the outermost moon, Europa goes round exactly twice. And Io goes round exactly 4 times. So that means that quite often the moons all line up like that. And that means that they give each other a gravitational tug, a gravitational kick. If we look at what that does with Io, instead of being in a circular orbit, it goes into a more elliptical orbit, or a kind of a eccentric orbit like that. So it spends some time close to the planet and sometimes further away from the planet. And when it goes from being close to the planet to further away, it gets stretched and squashed and stretched and squashed. And actually the surface of Io rises by up to 100 meters in the course of one orbit around it and then drops back again. And that means that it heats up. It's just like if you got a squash ball and start squashing it and stretching it, squashing it and stretching it, it'll heat up. That happens for Io as well. And so that provides an internal heat source to power the geology of Io.
And that power turns Io into a world beyond our imagination. Its unique gravitational connections fuel a seemingly inexhaustible supply of heat. And that heat doesn't only create vast lava lakes. It powers the largest volcanic eruptions in the solar system. As the molten rock and gas blast out from the frigid surface, the gas expands, shattering the lava into a giant fountain of fine particles. With weak gravity and a sparse atmosphere, Io's volcanic plumes can reach 500 kilometers above the moon's surface. In the most unexpected of places, in the coldest reaches of the solar system, the laws of physics created a fiery moon. Io, one of the 7 wonders of the solar system. Our exploration of the planets and moons orbiting our star has given us valuable insights into the nature of our own world. Our view of Earth's place in space has been turned on its head. All the other worlds out here are incredibly violent and inhospitable, but they're shaped by the same universal forces that created the Earth. It seems extraordinary that this haven exists at all. Until we started to explore the solar system, we had no idea what the laws of nature could produce. We now know how Mars became a dead world, how Venus suffocated in its own atmosphere, and how the force of gravity squeezes life into Io, the most volcanically active world in the solar system.